This is the first of two presentations on Six Sigma measures in this course. These are two common Six Sigma measures, defects per unit and defects per million opportunities. DPU, or defects per unit, is simply a ratio of the number of defects to the number of units produced, or the total number of defects found in a sample divided by sample size. To calculate, you simply divide the total number of defects by the number of units. Let's say, for example, that you're processing mortgage applications. This month, your organization processed 75 applications. In these applications, 12 errors or defects were found. We would divide the number of defects, 12, by the number of units, 75. There are 0.16 or 16% defects per unit. We multiply the decimal by 100 to find the percentage. So when we multiply 0.16 by 100, we find that about 16% of the mortgages had an error, but we need to remember that a single mortgage application could have multiple errors. Let's say we're making automobiles, and this month we produced 1,000 new cars. Automobiles are complex machines, and many things can go wrong. We found 9,000 defects in our automobiles. When we divide the number of units produced, 1,000, into the number of defects, 9,000, we find that we have 9 defects per unit. Some units may have more defects, and some may have none at all, but the average number is 9. Defects per million opportunities. For this measure, we want to convert our defects or errors to see how many there would be out of 1,000,000 opportunities. First, we should define opportunities. Every possible defect in a product or error in a service represents an opportunity. So from our mortgage application example, let's say there are 30 different fields that need to be properly filled out in the application. We multiply the number of fields or places where an error could occur by the number of mortgages processed. 30 times 75 equals 2,250 opportunities for error in our 75 units. To calculate DPMO, we first divide the defects by the opportunities. Then we multiply this number by 1,000,000. In our example, there were 12 errors, and we just calculated opportunities and found that the 30 fields on 75 applications represented 2,250 opportunities for error. Then we divided 12 by 2,250, and we get 0.00533. Multiplying this number by 1,000,000 gives us our defects per million opportunities of 5,333. If you've already calculated DPU, or defects per unit, you can use a little simpler formula. You can divide DPU, defects per unit, by the number of opportunities per unit, and multiply that by 1,000,000. As you can see, you'll get the same result. This measure gives us a different perspective regarding errors and defects. Let's turn to our automobile example again. We found that we had an average of 9 defects per vehicle, or 9,000 defects across 1,000 vehicles. Consider that automobiles are complex machines. There are a lot of opportunities for error or defects. Let's say there are 500 opportunities for a defect in each vehicle. Actually, there are probably many more. If we multiply the number of opportunities per vehicle by the number of vehicles, we find that we have 500,000 opportunities for defects. Remember, to get DPMO, we first divide defects by opportunities. We had 9,000 defects, so we divide 9,000 by 500,000. This equals 0.018. We then multiply this by 1,000,000. Again, we could use the shortcut since we have already calculated DPU, and the result is the same. Remember, defects per unit is simply the number of defects found in a sample divided by the number of units in that sample. To calculate defects per million opportunities, we first have to calculate the number of opportunities. We get this by multiplying the number of opportunities for error in a single unit by the number of units in our sample. This gives us the total number of opportunities. Then we divide the number of defects by total opportunities and multiply by 1 million. Or we can use the shortcut and divide DPU by the number of opportunities for error per unit and multiply that result by 1 million. In either case, the result is our DPMO, or defective parts per million opportunities.